So as a reminder, we will have a open note quiz on Tuesday, okay? We're on day 4 of this 3.12, and we have one more day, okay? So probably the most days we ever spent on any one section. So 5 days in 3.12. Mostly because I went pretty slow. Like today, I probably could have combined yesterday's and today's, but we're okay with time, so there's no reason to really rush. So Monday, I have one more type of problem to teach you, and the homework is like 4 of those new problems, and then I'm going to make up some problems that I think would be really helpful for you to review right before the quiz day on Tuesday. So if you're not here on Monday, please, please, please make sure you watch the video and be ready for the quiz on Tuesday, hopefully, okay, as we're going to review. All right, so we're still in the B part of this lesson, and you can see all the writing on here. If you remember, we did the sum and difference formulas today. So I'm zeroing in on this double angle formula today. We have 2 examples in our notes to go over. One is a review, basically, of the sum and difference, so we'll go over that, and then there's one like this, and then mixture of those 2 in your homework, okay? So let me introduce the double angle formulas to you real quick. These are written for you here. We have sine and cosine double angle formulas, and what this is saying is sine, let me back up. The u in these is just a variable. Okay, so I've been getting a lot of questions, like in one problem they'll have u, another x, and theta. Remember, they're all letters. They're variables. They stand for an angle. Whatever letter you see there means the angle. Alpha, beta, x, whatever. Okay, so, and you know I say you can use any letter you want. I switch to x a lot, all right, because that's just my hand starts using x instead of other letters anyway, so I just do that. So u in these 2 types of problems are an angle, a theta, okay? And so this is a double of the angle. You can rewrite the left-hand side to the right-hand side, these are equal to each other, to sine theta, cosine theta. One thing I want to say is that sine to u does not equal 2 sine u, okay? We know in algebra, like when we see things next to each other, it means multiplication, like x, y, z, that's x times y times z. And you could rearrange those letters in any order you want, right? But understand what this is saying to us. This is 2 times the angle and then finding sine of that. This is 2 times the sine of the angle, okay? So you do the sine of the angle and then multiply by 2. This is multiply the angle by 2 and then find sine. So these do not mean the same thing, so I just want to say that. But this can be written like this, but notice that's added on the cosine. Also with cosine double angle formula, there are 3 possibilities. They're all, I'll tell you where they come from in a second, but you can technically use any one of these in these problems. When for today's homework, we're actually finding, like, it'll say, find the double angle of cosine to something else, okay, whatever the theta is. You could literally use any one of these. They all mean the same thing and you get the same answer. When the different ones come into play usually is on a proof. So last year, my students didn't have to memorize all this stuff as I told you that. They had a reference sheet and they did actually harder proofs than you guys are doing in here because they had tons more formulas they had to pull from. We don't have even do half of the ones that they've done in the past. These are the ones that we've been memorizing and working with that College Board says you have to know. And so that's why we're working with those. And so what I'm getting at here is, you know, I tell you guys you have to memorize these, not for the open note quiz, of course, but going forward, you're supposed to know all of these. Really, if you know one of them, you know all of them. And I'm going to go over this one. This is the one I want you to really memorize. But you could have to know these other 2 in a proof where you're replacing something. You're replacing this with one of these to make it match the other side. And we'll talk about that more if and when it comes up. The big thing here, guys, is that your other AP teachers, every other AP teacher in the school has past AP exams that they, College Board releases. They're called released exams. So like AP World History, that's been around forever. And every year they release more mock exams. They'll say, this is the exam we gave in 2019. So the teachers have it, students have to look at. And you start to learn, you as the teacher, okay, they really don't focus on these formulas. You'll see a lot of questions like this. We have no idea what's going on for this year. And that's one of the reasons I think they're being so kind to us with the scoring on the AP exam. So I'm trying my very best to focus on what I think is important. You see I skip problems here and there. But, you know, as far as for my tests, you know my tests are going to be what I teach. Could something show up on our practicing and our reviewing that we haven't covered well or haven't covered at all? It could happen, but that's why we have a ton of time to review. So I just want you guys to know I'm keeping an eye on stuff. I don't just pick problems willy-nilly. I am really keeping my finger on the pulse of AP Pre-Calc with all of my other teachers in the country that we all talk about this stuff. So we are all doing our best with it, but understand when it comes back time for review, I might say, you know what, let's go back and review these. I'm starting to see these two pop up a lot. Or remember the Pythagorean identities? We only really talked about the first one. There were two other ones we didn't really talk about because I don't see them very often, but maybe during the review period we go back and revisit some of these things. That's what that time will be really good for. Okay, so I just want to say that. But know this one, all right? And by the way, this is subtraction, so order matters. Cosine, start with cosine. But these two, you really could come up with them if you know this one. So you don't write this. I just want to show you really quickly. If I took cosine squared, I'm going to make it x, minus sine squared x, and I wanted to come up with one of the other twos, all you're doing is substituting either one of these with its Pythagorean identity. Like cosine squared x is also 1 minus sine squared x, right? That's the Pythagorean identity we worked with a lot this week. And then I just brought that down, and then when you combine these two, you get 1 minus 2 sine squared x. And I won't bore you with it, but I could replace that guy with 1 minus cosine squared x and do the same thing, combine like terms. That's where those two come from, okay? So for now, let's just focus on our open note quiz. We'll have everything here anyway to look at. Your next test, which is of course not open note, this section's not on it, okay? Completely different stuff. That stuff, the artsy stuff, the polar, we're finally going to get to do that project. Okay, anyway, let's move on. So, like I said, we'll do an example like that in a second. Let me just first do another sum and difference problem. It's a little different. This is example 10. Okay, so this is going to review that sum and difference stuff. If you understood yesterday, you're going to be fine today because everything in this problem is a review. We have done tons and tons and tons of trig problems in this quarter in Unit 3. And every single time we did trig problems, we started on the unit circle, and then it would evolve off of the unit circle and do just any right triangle. Okay, we use SOHCAHTOA and Pythagorean theorem, right? Yesterday, we were doing specific right triangles, these, right, unit circle ones. Now we're just using the coordinate plane, drawing a right triangle, and coming up with it. So let me stop talking, let's do. So suppose that they give a sine of alpha is 4/5 in quadrant 2, and sine of beta is 1/2 in quadrant 1. Find this information down here. Well, let's just start with this and draw the triangles. So in quadrant 2, let's go ahead and remember how to draw triangles in the proper quadrants. We always just go hypotenuse out into the middle, make a right angle with the x-axis, and your theta is always at the origin. I'm going to call theta alpha just because it's there. It really doesn't matter. It's a variable, but it just makes it easier for teaching. Alpha is this angle. Any letter that you have there is the angle. Okay, and sine, don't forget SOHCAHTOA. Sine is opposite over hypotenuse. Now, thinking back to yesterday, when you do these formulas down here, the pluses and the minuses of sine and cosine, you need sine and cosine of each of the triangles. So they gave us sine, and let's go ahead and find cosine of this triangle, which means we need to find the adjacent side. You might recognize this as a 3, 4, 5 triangle. So this is 3, 4, and the hypotenuse is 5. This is going to the left of the origin, so it is negative. Don't forget, anytime you go to the left or down on the coordinate plane, you have to make it negative. If you didn't remember that this was a 3, 4, 5 triangle, Pythagorean theorem, you would find the same answer. And we'll do Pythagorean theorem on another problem in a second, but that's where that came from. One quick note, 3, 4, 5 triangles are very common. You see them all the time. Make sure 5 is the hypotenuse, though. Hypotenuse is always the longest side. It has to be the biggest number, okay? Because there's a triangle in your homework where, like, one of the legs is 5 and the hypotenuse is 3 or 4. That's not a 3, 4, 5 triangle, okay? 5 has to be the hypotenuse. These can be interchanged. All right, so cosine of this triangle is adjacent over hypotenuse. And I like to organize when there's a lot going on, I like to be really organized. You don't have to do this, and I'll say it again on other problems too. I like to put everything down here, even though it's right there. That's completely optional. Because when I go to plug into these formulas, I want everything in one place. I don't have to keep darting my eyes all over the place looking for what I need. So sine of alpha was given. We found cosine of alpha using Pythagorean theorem. Okay, then we have a quadrant 1 angle, beta. So I'm going to draw a triangle in quadrant 1. So hypotenuse out to the middle, right angle with the x-axis, and this is called beta. So I'm going to call it beta. And it gave us opposite sign. Opposite is 1, hypotenuse is 2. And looking ahead, I know I'm going to have to find cosine, so let's go ahead and finish this triangle. I'm going to have to do Pythagorean theorem on this one, so that would be 1 squared plus b squared equals 2 squared. So that's b squared equals 3, 4 minus 1. And b equals plus or minus the square root of 3. Do I need to see this work? Sure don't. In fact, if you are really comfortable with Pythagorean theorem, what's important to me is that I know you know how to find the missing side of a right triangle. If you are comfortable with it, for the homework, it's Friday, just steal mine, okay? I drew all the triangles in the homework, so if you know you're missing a side, just look up and take mine if you want to, just to save yourself a little bit of time today. Not that this is hard, but that's the point. Since it's not hard, I know you know how to do it. Let's not waste a bunch of time with it, okay? And we're going to the right, so I made it positive. So cosine is adjacent over hypotenuse. And for the same reason as I just said, I'm also going to write my sine of beta here, which was given, okay? And now it just makes it easier. I don't have to look anywhere but right here to fill these in. So I'm just explaining myself too much. Okay, so let's try not to look at the formulas from yesterday. Let's try to remember them like we did, all right? Just more chances to know that we memorized them. Cosine alpha is what it starts with. That's what we start with. My last period was being very judgy about how I draw my alpha. That's an A. That's a Greek letter A. It looks like a little fishy, kind of. That's just how I draw it. I'm not a good artist. Okay, so that's cosine of alpha. Cosine is shy, not as social as sine. So cosine likes to stay with cosine. And remember, alpha and beta, that order is non-negotiable. Alpha, beta, and when we do the second part of this sum, we will also have alpha and beta in that order. But cosine with a plus sign, remember we change. C is changed to minus. And now we do the same exact thing, but with sine. Sine alpha times sine beta. Okay? Good so far? Questions? Okay, now we just fill it in. Cosine of alpha is negative 3/5. Cosine of beta, square root of 3 over 2. Sine of alpha. See how it's kind of nice just to have it right there. You're not like having to go find everything on a triangle again or read the paragraph up there. I just like to do this like this, be really organized. And the same reason as yesterday, if you're multiplying fractions, you just multiply the numerators, you multiply the denominators. We don't need a common denominator. So here we would have negative 3 square roots of 3 over 10 minus 4 over 10. Another good discussion we had last period is all the different ways you could write this. For a open-ended question, like on a quiz, if this is a quiz and it's not multiple choice like the one that's on Tuesday, that would be fine. this would be fine. Or you could write this one like this, right? 4/10 can be simplified. Any of those three is full credit for me. Any of those three you could see on a multiple choice test. You wouldn't see all of them like an A, a B, and a C because they all mean the same thing, right? So understand when it comes to my test, the AP exam, it's about being a smart test taker partially, right? You have to be able to pick the right answer and not miss that one of them was negative or whatever, or you got this answer and you're like, it's not there. I don't know. I must have done something wrong. But being able to recognize this written like this, either one of those written like this. Okay? Good? Okay, let's do sine. Okay, so we start with sine alpha. You always start with the first one that's written there. Sine is the social one, so mixes with cosine. We keep the same sign in the middle. And remember, this is that moment I worry about. Are they going to do sine, cosine again, or are they going to do what's correct, which is cosine? And if you remember the other fact, besides the fact that you always go alpha, beta, alpha, beta, alpha, beta, there's no repeats here. So if I had put sine here, sine alpha, I would have been repeating sine alpha again, okay? And then use the same numbers and plug in. Simplify, decide how you're going to write your answer. So again, you could simplify the 4/10, write it all as one big one, lots of different ways. Okay, so there's a review of yesterday's off of the unit circle, okay? Because as a reminder, yesterday you would have had like pi over 6 and pi over 4 and pi's over 3s, so you would have gotten what I have in purple from your unit circle knowledge. Here, you're getting it off of a right triangle, okay? Last example, and that is 12. Here's where I'll do some double angle formulas for you. Find the exact values of sine 2 theta and cosine 2 theta. 2 problems in one, exactly how I did it on the quiz. There's a question just like this where you have 2 parts. And you're going to be given some information. And just like we did in the last one, we're going to have to draw the triangle and pull some information off of this right triangle. And so we're given cosine is 3/5, and our theta is in between 3 pi over 2 and 2 pi. What quadrant is that code for? Yeah, this is quadrant 4, and I'm sure you could have figured that out if you had to guess just by the picture, but understand that that means 3 pi over 2 is here, we know that, 2 pi is here, and theta is in between them, so that's quadrant 4. Okay, and so draw your right triangle in quadrant 4. Cosine is opposite over adjacent. Recognize this as a 3, 4, 5. I remember there being 3, 4, 5 here. Oh, wait. Huh. What's wrong? Something's wrong. Oh, what did I do wrong? Nobody caught me. Yeah, I was thinking of this as sine. This is opposite. It should have been here. I am so sorry. I knew something didn't feel right. Adjacent over hypotenuse. Okay, but still 3, 4, 5 triangle. 3, 4, 5. And don't forget, we are going down. So you have to make that 4 negative. Sorry, what? Okay, so trust me, you're going to need sine and cosine. Well, you don't have to trust me. It's right here. For either one of these formulas, we need sine and cosine, sine and or cosine, or both. Okay, so again, just me, I like to organize my information. Cosine was given to me. Cosine was 3/5, and sine is opposite over hypotenuse. So I'm going to be using these 2 exact values to find my double angles. So let's start with sine 2 theta rewrite it as 2 sine theta cosine theta. That's the formula. And let's just plug right in to the right-hand side. So 2 times sine of theta is negative 4/5. Cosine of theta, 3/5. Multiplication of fractions. We're doing lots of working with fractions. Let's really make sure we don't make mistakes on when do I multiply everything, when do I need a common denominator. Remember, that's 2 over 1. So 2 times negative 4 is negative 8, times 3 is negative 24. 1 times 5 times 5 is 25. If you can simplify, you do, okay? That one can't be simplified, though. Cosine 2 theta. Remember I spent a lot of time talking about that at the beginning of class? You can use any of the 3 formulas when you're fine. It doesn't matter, and I'll prove it to you. I'm going to use the one I want you to try to remember. But I'll show you in my notes. I have it done in a different method, but one of the other formulas, you get the same answer. Okay? So cosine squared theta. So cosine is 3/5. We're going to square it. You square the whole thing, hence the parentheses on the whole thing. And then sine is negative 4/5. Square that, and then find the difference. When you square a fraction, you square the numerator and the denominator, right? So we would get 9/25. When you square something, it's always going to be positive, so that's 16/25. Okay, now I'm subtracting, need a common denominator, have a common denominator. 9 minus 16 is negative 7/25. If I could simplify it, I would, but I can't, so I won't. Like I said, any of the 3 formulas would work. Here's where 2 cosine squared theta minus 1 was used. Plug in, you get the same answer. Okay, so any of those 3 will get you the same answer. Okay. Homework. We're in practice set 2. I think this is page 1. Help me. 147. Nope. 13 through 15, 18 through 20. Sorry about that. Page 147. Am I in the right place? I'm in the totally wrong place. So sorry. Right here. Is this still page 147 though? Okay. Thank you, Sadie. I apologize, guys. This is 145? Okay. All right, I'm going to do 13 with you, and I'll put the others on there. All right, so here's a sum formula. Theta, given in quadrant 2, and an angle we know. So in the one we did in our notes just a second ago, we had to draw 2 triangles. We only have to draw 1 here because we already know everything we need to know about pi over 6, okay? So we're going to go ahead and start out by drawing a triangle in quadrant 2, like it says. They gave us sine, which is opposite over hypotenuse. I need, I'm going to need that missing side right here, so I'm going to go ahead and take care of that right now. That's 3 squared equals 1 squared plus b squared. That's 9 equals 1. I think we all know how to do Pythagorean theorem. When you do the square root of 8, though, guys, that can be simplified. You need to simplify radicals. We would get plus or minus 2 square roots of 2. Remember, 8 is 4 times 2. Okay, that's a common one. I would just know it. Just kind of memorize it. Square root of 8 is 2 square roots of 2. Right? And we're going to the left, so that's going to be negative. I know for my sum formula, I'm going to need sine of theta and cosine of theta. Sine was given right here. And cosine would be adjacent over hypotenuse. So that takes care of the theta angle. Pi over 6, you don't have to write this. But don't forget, this is what we had to do yesterday, is remember cosine of pi over 6 is square root of 3 over 2, and sine is 1/2. Okay? So it's kind of mixing yesterday's type of problem, off the unit circle, and regular right triangle trig today's. All right, so we're going to expand sine of theta plus pi over 6. So sine theta, sine is social. We keep the sign in the middle. And now we just plug in. Sine of theta is 1/3. That was given. Cosine of pi over 6, square root of 3 over 2. Cosine of theta, -2 square roots of 2 over 3. And sine of pi over 6 is 1/2. Put it all together. And write it one of the 3 different ways you could really write that. Okay. All right. Now put the whole T up. Don't forget I'm checking D1 today. That was the sub worksheet. That's all I'm checking. So if you just want to have that out somewhere or know where it is, but keep working. It's a really quick homework check. It's like a manila color. And I did a whole bunch of phrases. You might have stuck it in somewhere. Look at Atlas. You see the paper that she put?
Yeah, I remember what it looks like. Can I like bring it on Monday or I'm not lying.
Oh, you
I did it on
can show it to me on Monday. It's just going to be partial.
um
Yeah, that's better than 0.
better than later.
Yeah.
9 times 5.
And then you just 9 times 75, right?
Yeah. Yeah. I mean, for me, I can't speak for your other teachers. Yeah. So you have 100% in AP pre-calc right now. Did you? The one grade I put in. Nice knowing you.
I think that was
Is it going to be something PE before this?
no. I ate a big breakfast too. I was like hungry. I use my lunchtime to do that, guys.